That's okay. Okay. So you're only off by 60, that's not bad. That's way better than government work. In fact, it's not government work because you underestimated. So they would have definitely overestimated. Okay.
Where does the S come from? I don't.
Oh, this is a 5, sir.
Oh, 5.
Sorry. That's my handwriting that's really bad. I'm going to do this from now on. I'm just going to work right with 5. I'm just kidding, I won't do that. So, maybe I can just like get some stencils and actually learn how to write. Okay. John, I'm sorry, sir. Is that better? Okay. Other questions, guys? Okay. So that's the decimal version of this. Let's get the hex version. Okay. So all I'm going to do is I'm going to chunk out, starting from the right, with 4s. So I'm going to have a chunk of 1101. I'm going to have a chunk of 1001. I'm going to have a chunk of 1001 again. And then finally, I'm going to have a chunk with just the 1 as the rightmost bit. But of course we know if it's missing some bits, we're just going to fill those missing bits in with zeros. Okay, so 0, 0. And it always has 4 bits. So, does that make sense, guys? I started from the right, and I just made groups of 4, starting from the rightmost possibility. Okay. Now, all we have to do at this point is just figure out what each of those are. Okay. I'm trying to think.
1,990.
Well, I was actually going from the right book. That's fine. Okay. So I looked at this one, guys, and didn't we just do 1101 in the previous example? So unless it just changed, okay, which it didn't, this is still going to be D, okay? And that's just because it's going to be 2 to the 0 plus 2 squared plus 2 cubed, which is 13, which is D. This guy right here is going to be 2 to the 0 plus 2 to the 3rd, okay, in order, I think you said it was 9, right, sir?
Mm-hmm.
For that one. Since the previous one was 1001 was 9, I'm going to guess that the subsequent is also 9. And then finally, 0001, that's just 1. Okay, we can all see that's 2 to the 0. So 199D, okay? And then when I write my answer, I just kind of smush it together. In other words, I juxtapose that answer. That's what it's called, juxtaposition, okay? So 199D in base 16. Yeah.
Are they always going to be the same? Like you said, this, if you can remember that.
Oh yeah, that's exactly right, Donnie.
You can
Yep.
start memorizing them.
Absolutely. If you want to memorize those rather than computing it each time, it will work every
Now, how
single
do
time.
we show our work for that? Just say we memorize it.
Yeah, that's fine. Or you can just write the decimal version of it. Like for example, like if you saw like 1110, you would just say, well, that's 14, which is it, and that'd be perfect for me. Okay. Go
How
ahead.
many combinations are there then? If you
15.
So you.
Or I'm sorry, 16. 0 through 15. There's 16 different ways that you can arrange those.
That really isn't too difficult to memorize.
It really is.
That's how I look at it.
So
Right.
So that's a realistic approach. Do you recommend that? Do you think that's a good habit to get into? To just see these and recommend?
It couldn't hurt. And I bet you probably a lot of them you're going to start recognizing just by doing the problems over and over again. Plus, think about this. Okay, Andre, what's this? In
0.
0. So you already know one of them, right? What's that?
1.
There you go. You're already what? 1/8 of the way there. Because that's, yeah, see? Victory. Good for you. But no, and I think it's valid what you gentlemen are saying, is that just by sheer, like some of them are easier, but some of the harder ones it might be beneficial to memorize.
So the zeros of these problems, like for the 9s, in between, they're kind of like placeholders.
That's
so
exactly right.
that you
Yeah.
do it first, but you don't really calculate that.
Correct. Yeah, because that's really like this guy right here. This is 2 to the 1st times 0.
Okay.
Doesn't mean anything.
Oh, that's why. Okay.
Right, okay. And if you want to think of it as a placeholder, that's fine. Okay. Other questions, guys? Go ahead, sir.
Is there an easy way to convert from hexadecimal back to decimal? Or do you have to go back to
What you would
binary?
do is you would take this, which is 13, and you would multiply that by 16 to the 0. You would take this 9, that would be 9 times 16 to the 1st. This 9 would be 9 times 16 squared. This 1 would be 1 times 16 to the third, okay? And that's how you can check your answer. Because each of these represents a power of 16 now.
Oh, so that's from hex to decimal.
That's correct, if you wanted to do that, okay? That's the intermediate, or that's the way to do it without going through the decimal, or the binary version.
And we always have to read from the right to left, right? Not
Yes,
from-
sir. You always start from right to left, which is counterintuitive, right, guys? Because when we read, we go left to right.
We're gonna have to go backwards. Like
No, sir, okay? I'm okay with, as long as you guys can get the binary, you can get to the other two. But no, I won't ask you to do that. Okay, does that help, sir?
Yeah.
Nice. And I bet you can do that very easily and check the 6557 if you want. Okay, other questions, guys? Okay, let's go ahead and take a look at if I wanted to convert to binary and hex. Okay. So we have our number 1, 2, 3 in base 10. Okay. Now, whatever way you guys want to do it, that's fine, as long as you don't cheat, okay? Let me show you guys the way that I think about it, okay? I start writing out my powers of 2, okay? So I go 2 to the 0, 2 to the first, and like above that you can write like 1, 2, 4, 2 cubed, which is 8, 2 to the fourth, which is 16, I hope I don't run out of room, 32, 2 to the sixth, which is 64, just would barely make it, 2 to the seventh, which is 128. As soon as I get to a number that's just bigger, okay, or that's bigger, I'm sorry, than the number I'm trying to convert, that's where I stop, okay? So I just keep writing out the powers of 2, and I know that it can't contain that bit. Okay, by the way, this is going from decimal to binary. So that way we know specifically which one we're looking at. Okay. So, what I'm doing is, I'm saying, okay, well, how many 64s are in 123? How many 32s are in 123 after I subtract? I'm basically just going to do continuous subtraction. Just like we did over here, we did continuous addition. I'm going backwards. So, I'm going to put a 1 under here because I can take 64 away from 123. Okay? As long as you can subtract the power of 2, you put a 1 underneath of that power of 2. Okay? 123 minus 64, that's going to be 59, I believe. Okay? My next possible bit, 32. I know that I can take 32 away from 59. So I'm going to put a 1 under this one, and I'm going to subtract 32. 59 minus 32 is 27. So see what I'm doing, guys? I'm just continuously subtracting. And remember, in binary, there's only 1. Okay? We can't put a 2 under here, because that would mean that we're in something like tertiary, which we don't want to deal with. I know that I can take 16 from 27. So I'm going to put a 1 under here. And then 27 minus 16 is 11. I know that I can take 8. Okay? So I'm going to subtract 8 from 11, which leaves me with 3. Now, I want you to notice when we get to 2 squared, I can't take 4 away from 3. So what I do is, I just put a 0 there. Okay? So basically, guys, all you're doing is you're just putting 1s in the places where you can subtract that power of 2. You put 0s where you can't subtract that power of 2. Okay? I know that I can take 2 away from that. And I know I can take 1 away from 1. And then, by the way, guys, there should never be a remainder. Does that make sense, guys? I mean, all we're doing is we're continuously subtracting powers of 2 that we can possibly subtract from it, okay? It's almost the inverse operation of what we did up there, where we added the powers of 2, now we're subtracting, okay?
Why don't you start dividing them by 2 and then reverse it, huh? You know?
Dividing by 2?
Yeah, so what it is, so 123 divided by 2, that's how much it comes to, then take a 1. You understand what I mean?
Oh, I see, that would give you the remainder.
Remainder, yeah,
Okay,
the
that's-
mod.
Yeah, you can do a modulus version of that as well, okay,
Yeah.
but we haven't learned div and mod,
Okay.
so I'm gonna stay away from that stuff. I know most of you guys probably know what a div and mod is, but I'm gonna wait until we get to proofs to do divs and mods.
So if I do it by mod, you're not gonna.
Oh, no, that's fine. Like I said, this isn't the only way to do this. This is the way that I know how to do it without teaching you guys like modulus functions or anything like that. Okay? Alright, so guys, this is our number right here. It's gonna be 1, 1, 1, 1, 0, 1, 1 in base 2. Now what I want to do is, like I said, once we get to binary, we're all good, because binary is like the mediator between the two. So, now what I'm going to do is I'm going to chunk 4s, 1, 1, 0, 1, bracket of 4, 1, 1, 1, and then the 0 is a bracket there. Okay. So now what we're doing is just like we did with the other two problems, we're just getting into base into our hexadecimal. Okay. I know that this is going to be 2 to the third plus 2 to the first plus 2 to the 0. That's 8 plus 2 plus 1, which is 11. But instead of 11, guys, what letter do we use in hex? B, right? So this guy right here, or girl, is going to end up being a B. Okay, does that make sense to everybody, guys? Just like the other ones. And this is one where, with Donnie and Andre, I think it's good if you guys memorize those instead of like having to do that all the time, okay? Although if you have to do it by hand, I mean, what does it take you, like 3 seconds? Okay? This guy is going to be 2 squared plus 2 to the first plus 2 to the 0. 4 plus 2 is 6, 6 plus 1 is 7. So it looks like that instead of having to write 1, 1, 1, 1, 0, 1, 1, which is tedious, we could represent that as 7b in base 16. Okay. Right. Does this make sense, guys? Any questions about how we're going to convert back and forth if I give you guys the decimal? Okay, you guys are going to convert that into hex, or I'm sorry, to binary, and then from binary to hex. Okay? Let's go ahead and do another one together just to make sure we're okay with the process of this. Okay, a little bit larger number this time. So this time we have 975. And as you guys can imagine, this is going to be a fairly big number to try to write in binary. Okay, so let's just try to beat it out of it. So 975 in base 10. All right. What we're going to do, guys, is we're going to start with 2 to the first 0, and we're just going to write up in powers of 2 until we get to a number just bigger than 975. Okay? So we have our 2 to the 0, which is 1, 2 to the first, which is 2, 2 squared, which is 4, 2 to the third, which is 8, 2 to the fourth, which is 16, 2 to the fifth, which is 32. So boy, this is going slow. 2 to the sixth, which is 64. 2 to the seventh, which is 128. 2 to the eighth, which is 256. 2 to the ninth, which is 512. And then finally, 2 to the 10th is 1024. And we stop with that. And by the way, guys, if you have your powers of 2 memorized, you don't have to write up the numbers above it, okay? I bet you a lot of you already have like your powers of 2 memorized up to like, you know, probably like 9096 or whatever it is, or 4096. So I'm not going to give you guys like ridiculously huge numbers, okay? I'm not going to give you anything in the millions or hundreds of thousands, okay? All right, so now what I'm going to do is I'm going to start at 512, because that's the number that's just smaller in binary. I'm going to put a 1 under that. We're going to subtract 512. And that's going to leave me with 463. Then I'm going to take 256 away from that, because I certainly can take 256 away. So if I do that, I'm going to wind up with 207. by the way, you should never get a number that's bigger than what's left over there, okay? If you do that, that means, either means A, you made a calculation error, or B, you just didn't go up high enough, or you skipped a power or two, okay? It never works out that you have like leftover stuff, okay? We can take 128 away. So minus 128, and that's gonna be 79, I believe. Okay. And then we can take 64 away from that, so we're getting there. Okay, this one's gonna be nice. So that leaves us with 15, I believe. Okay? And that means that we can't take the next 2 bits away, because 32 is bigger than 15. 16 is bigger than 15. So I'm going to put a 0 under here, because I can't take it away. I'm going to put a 0 under the 16. And then I know I can take 8 away from 15. That leaves me with 7. I know I can take 4 away from 7. Which is 3. I know I can take 2 away from 3. And I know I can take 1 away from 1. And by the way, this is the way the computer has to do it, okay? The computer can only think in very, very discrete terms of whole numbers, all right? So, unfortunately, this is fairly tedious for us to do as humans. Computers do it very, very easily. So, if I was looking at a number in base 2, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1. It's a palindrome. Nice. Except a binary palindrome. Okay. It looks like an emoji that like somebody's looking out from prison bars. So like if you're ever incarcerated, that's like the I'm in jail sort of emoji. Like here's the 2 eyes, and then here's all the prison bars. Alright, so just saying like if you ever get in jail, that might be good if you want to text somebody like, lol, I'm in jail, 1111001111. So, good stuff. Alright. I think the next thing we probably want to do is